So we're going to begin looking at Newton's first law of motion. We will begin looking at inertia. So inertia is basically an object's tendency to resist change in motion. So what that means, if an object is not moving, it's going to sit there and not move until something makes it move. Or if an object is in motion, it's going to continue with that motion unless something causes it to stop or slow down or speed up. So maybe an object, a car's traveling down a road, and if there's no friction to slow that car down with the tires, then that car would travel forever until it hits something that caused it to slow down. Think about maybe if you've ever ice skated before, where there's not very much friction between the skate and the ice. You just keep going until you hit the wall or you fall or you're able to create enough friction to stop. So inertia is going to be an object's tendency to stay in the frame of motion that it's in. This is going to be a quantitative measurement. So mass is going to define really how much inertia something has. So the more mass, the more inertia. So Newton's first law says that an object stays in motion or at rest unless it's acted on by an outside force. So if we look at this truck, this driver had a little problem with inertia. He's got a big concrete block there in his truck, and obviously it wasn't strapped down good enough because when the truck stopped, the concrete obviously didn't until it hit the cab of the truck. So your truck has brakes, the stone does not. So these next two slides we've got are some clips that I will link for you to watch later. This guy, his name is Paul Hewitt, and he teaches conceptual physics in Hawaii. He's got some nice 80s style going on, but I will link those videos below for you to watch. So the next thing we're going to look at is what's called mechanical equilibrium, which means the net forces on an object equal zero. So if I have something, a block sitting on a table, gravity is pulling down on that object, and then the table is pushing up. If gravity is more than the table can withstand to hold it up, then the object's going to keep falling down. The table is going to be pushing up with an equal force that gravity is pushing down. So the net force would be zero. They cancel each other out. Then we have what's called the normal force, and this is the force that opposes gravity. So like I said, if you have that object sitting on the table, gravity is pulling it down, the table's pulling it up. When we have objects that are moving, that are in mechanical equilibrium, they have to have an acceleration of zero. So this plane we looked at in the last set of notes, that plane can still be moving and have a net force of zero. As long as the thrust of the engines forward and the drag force of the air back are equal, then it's not going to be speeding up or slowing down. It's going to move at a constant rate of velocity, no acceleration. So these would be equaled out to zero. These would be equaled out to zero, but it could still be flying as long as it's not accelerating.